Tamamlar öncelikle ve bugün axırıncı gündür. Buna görə də indidən istəyirəm sizə təşəkkür etmək istəyirəm ki, you accepted our invitation and came to share your knowledge and expertise with us. Thank you very much, and I leave the stage for you.
Thank you. Good afternoon, everyone. I will just share my screen and we can start our last session. Yes, so today I will talk about inspection of equipment, my main focus area, my main career, I'd say, plan for now. Inspection of equipment, why it's needed, and applied inspection techniques. So let's start. Inspection of equipment. When we say that this is oil and gas facilities, this is like equipment, metal equipment, like consists of metal or different types of metals. What do we do with this? For example, we know that when we install any equipment on site, there is such type, like it cannot operate like till end of life without any issues. Like design life, in normal cases it's 25 years. This is like a design practice, but can we make sure that in 25 years nothing will happen with equipment? And if we install equipment on site, like even if apply coating or like if it's water system or not oil system, like fluid like transfers inside the equipment, it will operate in 25 years. No one can make sure that this is it's possible, it's happening. And if we put design life 25 years, it doesn't mean that in 25 years it will leak or like it will be degraded. It could be prolonged because like atmosphere, all conditions which affect material integrity, but in normal cases, in most cases, we cannot operate, we cannot keep equipment on site 25 years because of some affecting the degradation mechanisms. So what do we do? Even in this case, not only inspection or like monitoring, we split between how the disciplines, between all like engineering, that what is my focus area for this, like on site there are different types of equipment which need to be monitored, and not always like inspection techniques need to be applied there. It could be just like visual check, like where you are going to the site and saying, okay, equipment is good for operating, nothing is happening, and that's it. Like from integrity point of view, equipment is fit for service. Today's like our main course area, main program is about pressurized systems. So what is meant by pressurized system? There are, as I mentioned, different types of equipment. Maybe there is equipment which on site is operating without any pressure applied to him, neither internal nor external. And when we say pressure vessels, it's in our case, like in oil and gas industry, it's boilers and steam heating systems, pressurized process plant and piping, compressed air systems, heat exchangers, valve stream traps, and filters. So this is like for me, for pressure systems integrity engineer, main focus area that all these types of equipment are safe on site and nothing will happen during my monitoring and my predicted time that nothing will happen. So what incidents happen if I am not inspecting, I'm not monitoring my equipment on time on site? So it's a poor equipment, and or system design. Like if I am not inspecting, I don't know what's the design. Like I need to, when equipment installed on site, I need to first do inspection. It's called baseline inspection. So if I did baseline inspection and I know that if during installation of equipment, I don't have any issues, like no metal degradation. For example, if I've put wall thickness, like wall thickness is meant that material and like inside and outer, how we calculate wall thickness, like we have outer diameter for equipment and inner diameter, and when we like check like the outer diameter minus inner diameter gives us wall thickness. And wall thickness, it's our main how to say focus area. And even during installation, if it's we took from the company who is manufacturing this equipment and bringing to the site, not always this equipment is from integrity point of view is safe. Like some design problems can happen even before any startup of the equipment. Poor maintenance of equipment. For example, if we see that there is rainwater or some like leak close to equipment happening, we are not cleaning this area, we are not cleaning equipment on time, it's becomes leads to incident of pressure vessel. And as unsafe system of work, for example, if we designed for example, we bought this equipment and brought to the site for water operating, like operating water, like transferring water inside, but we are using for oil or vice versa. It's creating problem. So operator error, poor training or supervision. For example, we offer all pressurized equipment. We have pressure transmitters or temperature like equipment, like we're checking temperature or pressure. And if operators cannot predict that, for example, this designed pressure, for example, we put 50 bar for equipment as operating pressure, but it's increased to 80, and operator or control room technician cannot predict this on time. This leads to incident, even if it's material like metal wall thickness is in good condition, but pressure is increasing by wrong supervision. So poor installation. Again, we bring to the site, but we need to connect this equipment to a system. And if a connection on the site have been done improperly, there could be leaks from these connection points, and this also like falling to incident. And inadequate repair or modifications. For example, if we see on site that this material is degraded and equipment integrity is very close to loss of primary containment, we'll call it LOPC, and we repair, but repair was done improperly, this also leads to incident on site. So hazards. Hazards from pressure vessels, what happen if we do not predict everything on time. Impacts from the blast of an explosion or release of compressed liquid or gas. Impacts from parts of equipment that fail or any flying debris. Contact with released liquid or gas such as steam, fire resulting from the escape of flammable liquids or gases. I would like to say that by fortunate, I can say that till now in our I mean Azerbaijan, in our facility there was no any big fire or explosion which is affected population or affected any any living organism, but we like it's normal we have such like LOPCs leaks from equipment which we are mitigating doing immediate actions on time, like stopping operation, doing repair, and uh, 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 bringing equipment or service back to operations. So vessel failure, like as I've mentioned before, like which leads to failure of equipment. It's pressure in the system. Like if we design pressure and operating, like we put operating pressure in different like different number, but it's operating in different, like which is very close, very over or lower our operating design. We need to know about this in advance and provide monitoring on time and provide any control measures if we're changing pressure. Type of liquid or gas and its properties. Again, we should know all degradation mechanisms of fluid type what we are transferring inside the equipment. Suitability of the equipment and pipework that it contains. Age and the condition of equipment. As I mentioned, 25 years is design life in normal cases for each equipment we are installing on site, but aging, like at the beginning, like we don't have issues, like we're installing facility on site, we're okay with monitoring, with with controlling on site, but from time, like if it's like more than 10 years in operations, we need to make proper, much more proper controlling process and monitoring of equipment, complexity and control of its operation. For example, in normal cases in offshore platforms, in offshore, all equipment, all facility is contains in 4 or 5 floors, and sometimes to reach one equipment for monitoring, it's impossible because there is like piping or some different different equipment is installed very close, and we cannot reach this equipment, and it creates like constraints from the accessing this equipment, and sometimes it's providing very I'd say very big problems for us to monitor. Prevailing conditions, skills, and knowledge of the personnel and equipment on site need to be accessible, and personnel should know properly what this is equipment, what is equipment for on site, and this is all like if we are not following all processes which is written to follow, we like it everything lead to failure of vessel. So we talked about that what incidents, hazards, failures can affect pressurized vessel, and what we are doing to predict this. We are following 4 steps for each equipment of each pressurized equipment on site. This is plan, do, measure, and act. This is like 4 has the steps, like it's circle. We cannot like split. We cannot remove any stage for for monitoring, for controlling equipment integrity on site. So this is 4 steps which we are doing for any pressurized equipment on site. And starting from plan. What's plan? What were meant under plan? What do we do under planning stage? This is risk-based inspection called like this is like industry standards which are we are following, we are doing like we are owning this document, but again we are following this following equipment like to assign any inspection type for equipment. We need to know what the equipment type is, what the fluid type inside the equipment, what's the degradation mechanisms, like is it corrosion, erosion, is like a fluid contains microorganisms, how it's affect internally, externally, like atmospheric corrosion, like if it's insulated or it is coated. We need to know what the degradation mechanisms are applied. Equipment location, if it's onshore or offshore or above ground, underground. Design life is 25 years normally, but we need to know exactly from manufacturer what's the design life. Operating conditions, like what's the operating pressure, what's the operating temperature, how it affects our inspection techniques. Criticality of equipment, like how it's critical is equipment is this, like which is leading to probabilities and consequences, like if this equipment will corrode before time or will from mechanical point of view it will be degraded, for example, not in 12 years, what will happen? And we're calculating probabilities and consequences for the equipment and prepare risk-based inspection. And step do, what do we do? Like based on like identified all parameters what we're having in plan stage, we're applying inspection techniques, because all inspection techniques have limitations, pros and cons, which we can use or which we cannot use for any equipment on site. Susceptible locations, like were these locations, for example, if it's elbow, if it's like 6 o'clock position, for example, if it's horizontal piping, what can be like more degraded, more like risk for degradation part. It's if it's horizontal, if it is 6 o'clock, because fluid is moving and some sediments can be remained in 6 o'clock position, like in the bottom of the equipment. And if it's separator, if it's like tank, anything, we need to know susceptible locations. Inspection points, based on identifying susceptible locations, were identifying test points. You know that from a budget point of view and from integrity point of view, we're inspecting only 10% of equipment. For example, if it's 1,000 kilometers of pipe, we're inspecting only 10%, because sometimes like inspecting, we're not inspecting, like never we're inspecting 100% of equipment. Like mostly in this case it's piping. We're inspecting 10%, and based on the results of 10% of inspection of piping, we're identifying integrity, like fitness for service, that how safe this equipment for inspection. And inspection frequency, so when we are identifying operating parameters, design life, degradation mechanisms, we're identifying inspection frequency. How quick, how often we need to inspect. For example, if there is no any degradation mechanisms, but from aging point of view and from documentation point of view, we need to inspect this equipment. We are putting 10-year frequency, like every 10 years we need to inspect this equipment. But if there is, for example, it's very aggressive corrosion is going on, like its corrosion rate, for example, we are putting 0.1 year, 1 corrosion millimeter per year corrosion rate for like from a corrosion point of view for degradation of metal, 0.1 millimeter per year. And imagine sometimes it's even 3 or 4 millimeter per year. It means that like even if it's 25 millimeters wall thickness of equipment, and if we're predicting that even we're predicting that 2-3 millimeters per year, if it's degrading, it will be like fitness service like finishing for this equipment in 5 or 10 years, and inspection frequency is identified based on this, and planning of inspection on site. So what we are doing, like engineering part is done in this section, and this is execution. We are executing inspection on site, like preparation on site. For example, if it's insulated piping, and we cannot do inspection on this piping on insulated, or like coating degraded on and we need to remove coating to do inspection. This is just preparation site for inspection. And inspection itself, we are doing inspection, and this is under do part. So measure, we did inspection, we completed inspection, and what's happening next? We are doing our measurement, that how safe this equipment this equipment, based on doing corrosion rate calculations, remaining life calculations. So what is meant, like for short term and long term, we are calculating, and this is calculation formulas are taken from our industry standards. And what we do, like, and every piping and equipment have its own alarm level calculations, like we call alarm, like for each equipment, for each piping, we have 4 alarms. For example, if it's what does it mean, alarm 1? You know that for from material point of view, there is corrosion allowance understanding, like additional material applied for this equipment, and in most cases it's prevailing between 1.5 and 3 millimeter corrosion allowance applied for in most cases for piping and equipment. So if we lose half of this corrosion allowance, it's alarm 1 in and if it's we are fully lose corrosion allowance, it's alarm 2. And within alarm 1 and alarm 2, we are not doing any like any repair or any actions, because this is still like it's just 1.5 or like 3 millimeter loss currently happen, and we're just monitoring equipment. But if it's alarm 3 or 4, like 4 is like our last stage, it's there is a definition minimum allowable wall thickness, like which is starting from this point, definitely we need to repair, and definitely if we will not do anything in 1 year or like even in 6 months, material will be like degraded, and leak or incidents may happen. And based on these calculations, and some equipment, for some equipment we don't have corrosion allowance, and for this calculation is going differently. But again, starting from alarm 3, from our definition from industry standards, we are taking any precautions to not like keep equipment in this position on site, and this is goes to act. What does it mean by act? Process is raising anomaly. So for example, we have anomaly system. So if anything goes wrongly on site, material degraded or corroded, or insulation breakdown happen, we are raising anomaly in system. Anomaly is meant that something is happened not properly on site. So and it goes to repair, and by repairing either changing this equipment, we call it's like for like, or we're doing like installing any clamps like to mitigate this area. And after doing this, after repairing, we're doing like risk-based inspection assessment. So it's like continuous chain. So this is like overall process, like what we are doing from a pressure engineering point of view, like plan, do, measure, act. And what's helping us as an engineer, I cannot go to the site and say that yes, it's safe or not safe. Like from external point of view, yes, I can see, but from internally, I cannot predict anything because I cannot see inside equipment. And in most cases, like from in new world, we're moving away from like entering inside the equipment, and we want to uh, go to equipment, do not stop any operation, and we want to see what's happening inside. And there are several tools which are helping us, which I will uh, talk about in a few minutes. So as I mentioned, there are different techniques based on their limitations, based on their advantages, cost, or like manufacturers impacting. While defining what equipment we have. And I will show you just several of them because it's very big amount of equipment tools we are using on site for inspection of our equipment. One of them is phased array. You can see how it's work like this. By doing this, we're checking, and you can see here, this is blue color is metal, and you can see colors like how like this is showing that in this place metal is degraded and some loss is happening here. And based on this, like you can see here, monitor, in this monitor is showing that, for example, nominal wall thickness is 9 millimeter, for example, wall thickness measures, but here it's remain 3 millimeters, and this is a part of measuring. And a phase array is very, how to say, widely used in our facilities. This is one of the best tools. Like this is similar to ultrasonic. Maybe you have heard about this. Like ultrasonic. This is similar to ultrasonic. What people have in their checkups, like you are going and there is tool with measuring what are how in which condition your internal organs. Similar to this, we have this equipment like ultrasonic equipment, and there are the different types of ultrasonic equipment we are using. Like this is just like call Uzi of our equipment. So uh, and advantages for this equipment is radiation free, ultrasonic. So oil and gas industry have very big number of radiation, and this equipment, if we are bringing this equipment from radiation point of view, we will not have any issues. And this is one of the best tools like to inspect our equipment, not only piping. This picture of pipeline, but we are using for our vessels separators as well. Welds from quarter inch inch in diameter up to flat like plate may be inspected. So as one of the advantages of this equipment, of these tools, that we can inspect even very small, like less than 1 inch diameter piping, as this is very useful practice. So this regarding limitations, as I mentioned, like we cannot apply this technique insulated system, we need to remove insulation, and to remove insulation we need to know operating parameters. If it's like insulation is, why is insulation applied on site, is due to, in normal cases it's for personal protection, because it's hot system and anyone can go near and touch and burn himself and or herself, but in normal conditions, like we cannot remove insulation, only if for inspection, and surface preparation is required to allow the collection quality data is meant for as insulation. So and like if it's insulated, we cannot apply this equipment. And if we cannot remove due to operating condition, because we have systems where it's 200 Celsius degree, we cannot apply this technique. Ultrasonic, like another type of UT, ultrasonic inspection, is corrosion mapping. So this is tool which is moving, like taking a little bit bigger area for inspection. It's moving, and this also can be applied on different type of equipment like pressure vessels, pipe work, reactors, storage tanks, ship hulls. Like in our case, it's like first four are more applicable for us. So this is by doing this inspection, we don't need to enter equipment. We can externally see what's happening inside the vessel. When I mean inside, like when I talk about insides, I mean internal part of metal. Like this is external part we are inspecting, and by doing this inspection, we are seeing that what the degradation happened internally on this equipment. And this is tool like what is showing, like red colors means that there is some degradation happened, and there is some actions need to be taken. So radiography. So regarding radiography, this is similar to Röntgen. There is piping, for example, and we need to know what's happening. When we apply this radiography inspection, you see similar to Röntgen, showing what's the condition of piping. You can see here a wall, like its internal and outer, inner and outer diameter, and this is wall thickness. This is nominal wall thickness, and here is a numbering that what's measured in each point. And based on this, for example, here we put all parameters for this piping. For example, if we put that 6.5 millimeter is nominal, that must be 6.5, and what were measured, like actual and a nominal, like we are checking versus this, and this is reporting format. What we are doing, like we are having reporting reporting process for all equipment, for all inspection we're applying. And here you can see that test points, which condition, if it's elbow, weld, and like what's the nominal parameters, and what's the measured, and like even position of like film, like it's radiography and there are films, and if anything happen, like here is from normal condition, any observed abnormality, we put in comments and raising anomaly. One of the biggest problems for oil and gas industry is inspection of big storage tanks. And in big storage tanks, we are keeping like storaging water or glycol or oil, condensate, different types of tanks. As an example, I would like to show regarding inspection of storage tanks. This is Sangachal facility, and we have one of the biggest tanks, like even like from diameter point of view, this is one of the biggest, but from designing point of view, like this is the largest single deck tank is located from in the world, located in Sangachal terminal, and there are three. You can see here from in the photo, in the scheme. So this tank have 96 meter diameter, height is 20 meters, and volume is 800,000 barrels. Like imagine how big this tank. Like it's like similar to football square. And like if you are going around of this tank, it takes too long for you. What we have for tanks, like they're sitting on the ground and they are not accessible from all parts. We can inspect from like with ultrasonic inspections, with radiography, uh, supports of this equipment, shell shell parts or roof, but flow where tank is sitting on the ground, we cannot inspect. And to inspect this tank, we need to take this tank out of operations for 6 or even for 1 year. And because it's 96-meter diameter, and imagine cleaning processes. And this in this picture, you can see internal part of tank, and like the personnel is cleaning of equipment to prepare a tank floor for inspection. And worldwide, and from production point of view, we are losing such a big amount of money just to inspect this tank. And in normal condition, in most condition, there is no repair is required, just inspection. And what we are doing, like as an engineer, what we need to do, we need to optimize our scope. Like we cannot just go to say that to companies that to inspect this tank, I need to take this tank out of service for such amount of time. And what we are doing as pressure systems integrity engineers, we are finding worldwide techniques which are applied and which based on what we do not need to take, like to not affect production, like oil or condensate or meg will keep kept on site inside the vessel, inside the tank. Operating condition will be normal, everything will be normal, but at the same time I will inspect my tank and to see what's the integrity of equipment. So what we did as a practice, like first time in our company history, this was actually my project. So to apply non-intrusive, like non-intrusive, it means that you are not enter inside the tank, inside the equipment and do your inspection, you know, integrity. This tool you see here, it was first time applied in history of our company. This is a robot called like we call this crawler. And in overall, the project was internal robotics inspection. And you can see from process point of view, like a tank is operating is in normal conditions. Company like employees are entering the robot from the roof because tank is full of a tank is full of oil, and they're like standing on the tank roof and fully like 20 meters and 96-meter diameter with 20 meters height, full of oil. And if anything will happen, imagine how big explosion could happen. And employees are like entering this robot inside the tank, and tank is robot is moving inside, like inside this person. Tank is moving in the inside the tank and taking like measurements and providing us what's integrity of this, how safe is tank floor is. So this was a very successful project, and as lessons learned, our different regions are applying this technology. Different companies have used, but our company have used it first time in 2019 and 20. Heat exchangers. So we have heat exchangers in our facilities, which is one of the main equipment which we are doing, having outside. So imagine like we have heat exchangers, in most cases, like there are two different types of heat exchangers. In most cases, we have a tube and shell, like uh, heat exchanger bundle, like this, you can see here. Bundle is sitting inside the shell, and in most cases, we need to inspect them differently, separately. So from inspection program point of view, what we are doing like this process you can see in picture. As an example, this is heat exchanger in one of our facilities, which have 2080 tubes. And like this is just a photo of it. 2080 tubes must be inspected to see integrity, but what we are doing, we are inspecting only 10% of tubes, and this is not just randomly checking. This is more susceptible areas inside this tube heat exchanger, and tubes have been selected based on industry standards like tube inspection plan. This is plan have been provided to technicians on site, which part of need to be inspected. And what we are doing, like this is just photo have been taken from internet because this is a little bit confidential and I cannot share ours. So this is iris tool, like this is just small camera on the hose, and they're entering inside each tube, like diameter is very small. And this tool, like iris is called, is internal rotating inspection system. So a tool is moving inside the pipe tube and showing what's the condition. In our case, not normally see what's the wall thickness and this can measure wall thickness and can show us what's the condition of each tube, and based on this we are seeing integrity. But about regarding shell of the inspection, we are doing external inspection. So for this session, I have brought like 5 types of inspections that commonly mostly used in our industry, and this is like every year, from year to year, it's changing, and techniques becoming more advanced, more like useful on sites. Sometimes, like even if we like wonder how this technique is working and what the result is giving this technique to us. So and even if it's more like we're using robots, we're using different technologies, we're unmanned, let's say, but for preparation of this, for preparation, providing inspection plan, we need our engineers, and this also like ongoing process. And from pressure systems point of view, we are having plan for each of our equipment, and each equipment under control, under monitoring, and we are luckily provide proper inspection plan for each equipment, and we don't have big issues, big concerns on our sides. So that's all from my side. If you have any questions, you can address regarding inspection plan or techniques. It's finished, Hakan.
There is a question in the chat section. It says, Talia says that, thank you for the great session. I want to ask a question just for the future, and she's writing now her question.
Okay.
She says that in Azerbaijan, in how many years will we be alternated with the robots, or which engineering discipline?
Where To be honest, we have targeted plan within company for each decades. For example, for 2030, we have like a plan for which engineering and which technology will be unmanned, like remote, which platforms will be remote, because we and from engineering point of view, for each decade, for 2020 we had plan, and some engineering disciplines became archive in our company. For 2030, we have a plan of list of engineering of like programs or engineering disciplines, which will be like archived by 2030. Currently, our plan for 2050, it's not like it's not set, but for 2050, we have, even in 2050, we have a big amount of how to say amount like a plan for engineering. Like engineering never ends. Even if we are doing this remotely, this is done by engineers, and we need to have engineers always in our, how to say, facilities, in our companies, to manage this process, because robots cannot go to the site and do everything itself. Some engineers need to manage this. From safety point of view, this is that it's remote control. Remote control is very good, useful from safety. Like if something will happen, we will not lose any human on site. And our approach, our plan is not just remove of engineering disciplines. To remove engineering disciplines, to remove personnel from site, to make it remote, but at the same time have engineers in our facility, like in our company. And regarding this 2050 year plan is already prepared. Again, we have very big, how to say, so we need very big support from engineering. I am as well, like sometimes I'm thinking that when my discipline will be finished, like when I will not be needed, even in this case, I am preparing like myself for different type. For example, if everything goes to robotics, how can I apply my engineering skills to become a more like valuable person within company by being engineer, but not doing just inspection on site. Like everything, like any type of engineering will be modernized, but not be, let's say that no, I don't need you, but I need you more, how to say, modernized, more how to say, qualified, not just doing just inspection on site in our case. So yeah, I think
Yeah,
I
she
think that.
said, it is clear. Thank you very much once again for your time and informative session, she says.
Thank you. Thank you.
If there is no any question, I think we can end the session. Again, I want to thank you very much for coming here. As always, we have learned a lot from today's session too. Wish we can see you in our next future sessions too.
Thank you. I hope so. Good luck to everyone. Have a nice like studying life.
Thank you.